Good morning, students. Yesterday we discussed about different types of unit cells, and we shall also calculate the number of particles present in primitive or simple unit cell, cubic, that means face centered, and also body centered unit cell. So body centered unit cell has total number of atom 2. Face centered unit cell has total number of particle 4. You know how to calculate the number of particles present in simple cube, body centered cube, and as well as face centered. Are you clear? Okay, again we shall study about the two-dimensional and one-dimensional packing. See, in solid, all the particles are said to be a closed sphere, and their dimension in one dimension, coordination number is 2. In the two dimensions, we have two possibilities. One is square, another one is hexagonal. Are you clear? When the spheres are placed one below the other, we will get a square geometry, and coordination number is 4. If the spheres are placed, second layer spheres are placed in the depressions of the first layer, then we will get a hexagonal geometry, and its coordination number is 6. We studied. And in three-dimensional packing, by using two dimensions, so we will get the void. Those are tetrahedral void and octahedral void. We studied that also. In tetrahedral void, so tetrahedral voids are formed by the 4 spheres, and octahedral voids are formed by 6 spheres. The number of octahedral void be n, and number of tetrahedral void is 2n. Are you clear? So that is nothing but which we discussed in last class. So locating the tetrahedral void and octahedral void, and three-dimensional arrangement can be obtained by two dimensions. That is AB type packing and ABC type packing. The third layer is similar to the first layer. For example, you will get a cubic close packing, which is nothing but a copper which is exhibited. In a hexagonal close packing, which is exhibited by the metals like magnesium. So these are, it's a closed packed structure. See, in packing efficiency, what do you mean by packing efficiency? Define packing efficiency. The percentage of space filled by the particle is called what? Packing efficiency. Are you clear? If the percentage of packing efficiency is less, then the solid contains more voids. Are you clear? It's a simple analogy which you can easily remember. Are you clear? So today we shall discuss about different packing efficiencies. Calculation of packing efficiency in face centered cube, or which is nothing but a CCP or HCP. Then also again you have to calculate calculation of packing efficiency in body centered cube and packing efficiency simple. Are you clear? See, we discussed about different types of packing, which is nothing but one-dimensional, two-dimensional, and as well as three-dimensional. The real figures, which is nothing but a three-dimensional packing. In the three-dimensional, we have AB type packing. Another one is ABC type pattern, which are obtained when the spheres are placed in the depressions and as well as one below the different layers we have to place. Okay, and today we shall discuss about calculation of packing efficiency in CCP. See, calculation of packing efficiency in CCP or HCP, or which is also called nothing but FCC. Are you clear? See, first we have the diagram, say which is nothing but a cube. I am going to draw this. See, we can have this diagram, which is nothing but a cube here. So this is nothing but the face diagonal. We call this as A. See, I will write by color chalk, which is nothing but A. So this is B, C, and D. Are you clear? So this is E, F, G, H. Here we have to calculate the packing efficiency. What do you mean by packing efficiency? It is nothing but the percentage of the space filled by the particle. Percentage of space filled by the particle in a solid. This is called packing efficiency. We are going to calculate the packing efficiency in cubic closed packing, or which is also called hexagonal closed packing, which is nothing but an axis. Here you have to draw a face diagonal AC. Just join this AC face diagonal. Are you clear? So this is how to draw. And here consider a cube. See, consider a cube with edge length A. Are you clear? With edge length A. Consider the cube with edge length A. Then see, this is nothing but the diagonal. We have a triangle ABC. See, and the diagonal AC is equal to B. We'll call this as B. And these are nothing but the sides, which is nothing but A and A. So in the triangle ABC, in the triangle ABC. See, we have ABC. AC square is equal to AB square, then plus BC square. Are you clear? A simple one we can see, which is nothing but, see, AC square is equal to AB square plus BC square. Are you clear? Then see, AC is nothing but B square is equal to A square plus A square. So you got B square is equal to 2A square. Are you clear? Then B is equal to root 2A. See, the face diagonal B consists the three spheres. We can have the spheres. See, one. So this is another one, which is half portion is outside, and this is another. Are you clear? The particle is said to be a circular sphere. The volume of the sphere we have to take. So you can find this is nothing but radius of the sphere, or an atom is considered to be spherical, therefore its radius. Again, this V is equal to, we can find 4R. Here you have to consider the radius of sphere V R, then V is equal to 4R. So therefore 4R is equal to root 2A. Are you clear? Then R is equal to you got root 2 by 4. What about A? We will get A is equal to 2 into root 2R. So this is very important. Are you clear? So we write at the top, which we call R is equal to root 2 4. Then what about A? So you write A is equal to say you will get 2 into root 2R. Are you clear? So that is nothing but the edge level. If it is a cubic closed packet or HCP or in FCC, the number of particles are, so you know, so the FCC unit cell contains 4 particles or 4 atoms. So therefore volume of 4 spheres. Volume of 4 spheres. What is the value of 4 spheres? It is nothing but 4 into 4 by 3 pi r cube. The volume of the sphere is given by formula 4 by 3 or pi r cube. Are you clear? Understood? And then see, this is nothing but volume of the sphere. How many spheres are there? 4 spheres. So what is the packing efficiency? Packing efficiency. So you have to write the formula very clearly. So that is nothing but volume occupied by 4 spheres in a unit cell. See, this formula carries one mark. Volume occupied by 4 spheres, 4 unit cells divided by total volume of unit cell. Total volume of unit cell into 100. Packing efficiency is nothing but the percentage of space filled by the particle. So therefore it is, say, volume occupied by 4 unit cell divided by total volume of the unit cell. What is the total volume of the unit cell here? Say it is nothing but total volume of unit cell is nothing but A cube. Is it so? What do you mean by A cube? A cube is nothing but 2 into root 2R, the whole cube. Now you have to just substitute the value. We can easily substitute the value. So therefore is equal to just we can substitute the value. Volume occupied by the 4 sphere is, say, 4 into 4 by 3 pi r cube divided by, see, it is nothing but A cube. A cube is nothing but 2 into root 2R the whole into 100. Are you clear? See, just you are substituting the value here. 4 into 4 by 3 pi r cube divided by 2 into root 2 r cube, which is nothing but volume, total volume of the unit cell. What do you mean by total volume of the unit cell? It is nothing but 80. It is nothing but 80. Are you clear? So you can easily calculate them. So this is nothing but here cube 8 and 16 just cube, and you will get the value as 74%. Are you clear? Say R cancels out. Instead the value, then we have 16 by 3 and 2 the cube is 8. No need of again showing mathematical calculation. Just write the percent. You will get 74%. Packing efficiency in FCC is packing efficiency in FCC is 74%. Are you clear? See, dear students, very clearly you have to draw the diagram and then you have to do the derivation. Are you clear? What is the derivation? See, consider a cube with adjoint A. You have to be a particular diagram. So, diagram which is there in your NCERT textbook. See, many notes and many textbooks are referring different types. Don't worry about it. So diagram you have to draw according to your textbook, NCERT textbook, and you have to do the calculation. You have to do the calculation. So here consider the cube with adjoint A and a face diagonal AC is equal to B. AC is equal to B. Then in the triangle ABC, AC square is equal to AB square plus BC square. B square is equal to A square plus A square, and B square is equal to 2A square. Then B is equal to root 2A. Are you clear? B is equal to root 2A. Then say radius of sphere is B. Therefore B is equal to 4R. You can see here one of the sphere and other two spheres are half in this diagram. So therefore B is equal to what? 4R. Then 4R is equal to root 2A, what we got here. Then R is equal to root 2 by 4. So this is nothing but radius in FCC or CCB unit cell. What is the value of R? R is equal to root 2 by 4. Again, see, what is edge length here? Edge length is equal to 2 into root 2R. FCC unit cell has 4 atoms or the 4 particles. So therefore, the volume of 4 sphere is 4 into 4 by 3 pi r. Then very neatly you have to write packing efficiency formula. That carries 1 mark. Very clearly you have to write packing efficiency formula. Are you clear? So that is packing efficiency is equal to volume occupied by 4 unit cell divided by total volume of the unit cell into 100. Packing efficiency is defined as percentage of space filled by the particle. As it is percentage, you have to write it to 100. Then just substitute the values. That's all. 4 into 4 by 3 pi r cube by 2 into root 2 r 2 into 100. You will get 74%. Okay, that is nothing but the calculation of packing efficiency. In CCB or HCB. Are you clear? So we derived one packing efficiency calculation of FCC and we got the value 74%. Or then remaining 26% is the space, which is the empty space. Are you clear? So FCC is more efficient than other unit cell, even in body centered unit cell. Many particles are present, so it is the stable. Are you clear? Then next, shall I rub this? Okay. Then we shall study about packing efficiency in body center. Packing efficiency in body center, in BCC. Packing efficiency in BCC. Packing efficiency in BCC. Shall I have this? Packing efficiency in BCC. Are you clear? So, what is the percentage we got in CCP or HCP? It is nothing but 74%. Now we should study. The packing efficiency. The packing efficiency in packing efficiency calculation of packing efficiency in BCC body center cubic unit cell. Are you clear? Body center cubic unit cell. Now we have to draw it. I will draw it here. See, which is nothing but a cubic unit cell. Can easily draw this. We just draw here. So this is nothing but a cubic unit cell. Are you clear? A cubic unit cell. Now you can say, so you have to take which is nothing but A, B, C, D, then E, F, G, H. Are you clear? So small construction you have to draw is, so this is nothing but one of the small construction you have to make. See. And this is nothing but the, now this FD will take as B, and this is nothing but the, say, body center. The particles are present at the center of the body, so therefore it is C and one is as C. And as the spheres again, so this is one of the sphere, and another sphere is just outside this, and another is also outside. Only half portion is in the inside. See, this is nothing but the relevant cubic diagram which you have done. Are you clear? So consider a cubic unit cell with edge length A. With edge length A. Are you clear? Consider a cubic unit cell with edge length A. Then, see, as this is nothing but the triangle FED in the triangle. FED. See what you will get? FD square is equal to. So you will get FD square equal to EF square plus ED square. Are you clear? Now substitute the value. So this FD is nothing but B. See, B square is equal to A square plus A square. So this is nothing but A, and this is also nothing but A. Are you clear? Now B is equal to, see, B is equal to, what you will get? 2B square. B is equal to U1. See, 2A square. Are you clear? It is nothing but a B square. B square is equal to 2A square. Now, we have to consider the triangle. AFD. We have a side of 2A, which is nothing but 2A square. So therefore, we made a small construction. We have to join FD. So you have to write here, join FD, which is equal to FD is equal to B. FD is equal to B. Are you clear? So now, triangle, see, AFD, are you clear? In a triangle, AFD. See, AF square is equal to FD square plus AD square. FD square plus AD square. Are you clear? Now, AF square is nothing but C square is equal to FD is nothing but 2A square. We got FD square is equal to B square, which is nothing but 2A square. Then AD square is A square. So you got C is equal to 3A square. C square is equal to 3A square. Then you got C is equal to root 3A. Are you clear? You got C is equal to root 3A. Understood? We got C is equal to root 3A. So what about C? C is equal to 4R again. Very simple. So this is R, again another R. So totally C is equal to 4R. Now you got 4R is equal to root 3A. Now you got R is equal to, this is also R is equal to root 3A by 4. What about A? A is equal to, we got A is equal to, see, A is equal to 4R by root 3. We got A is equal to 4R by root 3. Are you clear? So you may get some CET question. So they are going to give radius of the sphere in BCC. You have to calculate the HL. So A is equal to, you have to remember, A is equal to 4R by root 3. Are you clear? We are calculating now packing efficiency in body centered cubic mixture, which is nothing but BCC. So we derived what is R and what is A. So you have to draw the cube with edge length A, and you have to take here small construction. You have to join FD. As it is BCC, the particles are present at face diagonal, as shown in the figure. Now you have to take in a triangle FD square is equal to EF square plus ED square. Are you clear? Then in the triangle, AFD, you got AF square is equal to FD square plus AD square. Now C square is equal to 2A square plus A square. Then C square is equal to 3A square. So therefore C is equal to root 3A. C is equal to 4R, and 4R is equal to root 3A. Are you clear? 4R is equal to root 3A. Then R is equal to root 3A by 4. Root 3A by 4. And A is equal to 4R by root 3. A you got 4R by root 3. Now, how many atoms or particles are there in BCC? You know, there are only how many? 2 particles. So therefore, the volume of 2 spheres we have to take. So next we have to write. The particles present in BCC, total number of atoms is 2. So therefore, volume of spheres. Volume of two spheres is equal to 2 into volume of two spheres is equal to 2 into 4 by 3 pi r cube. So this is nothing but the volume. Are you clear? So volume of two spheres is equal to 2 into 4 by 3 pi r cube. 2 into 4 by 3 pi r cube. Now what is packing efficiency? Right. The formula of packing efficiency. Packing efficiency is equal to see volume occupied by two spheres, two unit cell divided by total volume of units into 100. Don't forget to write into 100. Are you clear? Packing efficiency is equal to volume occupied by two unit cell and total volume of unit cell into 100. See, into 100, which you cannot observe. So into 100. So therefore, that is nothing but volume occupied. So that is nothing but 2 into 4 by 3 pi r cube divided by. See, a value you got. What is the a value? 4r by, which is nothing but 4r by root 3 root 3 r. See, root 3 4r by root 3 the whole. Are you clear? Into 100. Just to calculate this. See, 4 the cube 64, then root 3 and 4 to the 8. Pi r cube r cancel off, and root 3 goes to numerator, and you will get 68%. We will find the value as 68%. No need to show all the mathematical calculation. Are you clear? So therefore, packing efficiency in a body-centered cubic unit cell is 68%. Packing efficiency is defined as volume occupied by two unit cell, because BCC contains only two atoms. Then total volume of the unit cell, which is nothing but the edge length value, which is derived by taking the angles. By taking in the triangle, all we have derived A is equal to 4r by 3. Are you clear? And then we got 68%. So therefore, in body-centered cubic unit cell, only 68% of space is filled. The empty space is more in body-centered as you compare to face cell. Are you clear? As you compare to FCC. Okay. So that is nothing but calculation of packing efficiency in BCC unit cell. So I will repeat again. So we have to draw a neat diagram. Then consider a edge length A, and you have to join FD, where FD is equal to B. In the triangle, FD square is equal to EF square plus ED square. Then B square is equal to A square, B square is equal to 2A square. As that is nothing but the value of B. And then see, you have C is equal to root 3A, then 4R is equal to 3, and A is equal to 4R by root 3. And then in BCC, total number of atoms is 2, volume of sphere is 2 into 4 by 3 pi r cube, and packing efficiency formula which carries 1 mark. Very clearly have to write the formula. So that is packing efficiency is equal to volume occupied by unit cell divided by total volume of the unit cell into 100. So 2 into 4 by 3 pi r cube divided by the root 3 What is the packing efficiency you got in VCC? It is nothing but 68%. Are you clear? So that is nothing but calculation of packing efficiency in body center cubic unit cell. So we shall continue our discussion on calculation of packing efficiency in simple group. Okay, calculation of packing efficiency in simple group. So I am going to do this calculation of packing efficiency in simple. Are you clear? So we derived two packing efficiency. One is FCC or HCP, another one is BCC. BCC shows 68% packing efficiency, and packing efficiency in simple cubic units. Unit cell. Are you clear? So in simple cubic unit cell, draw the diagram. See, a simple cubic unit cell, draw. So which is nothing but a simple cubic unit cell. The particles are present. See, this is nothing but one another. See, these are nothing but the two spheres we can find here, and other particles are there over here. So these are the only two spheres we can find. And this distance which is nothing but r, and this is also r, and we will get A is equal to 2r. A is equal to 2r. So consider a cube with edge length. See, with edge length A. Are you clear? In simple cube, see, as A is nothing but A is equal to 2r. A is equal to 2r. Are you clear? So how it is? What is the total number of atoms? So total number of atoms in simple cubic unit cell is equal to 1. So therefore volume of one sphere is equal to 4 by 3 pi r cube. 4 by 3 pi r cube. Very simple. What is packing efficiency? You have to write down. Packing efficiency is equal to volume of one unit cell divided by total volume of unit cell into 100. So that is nothing but the packing efficiency formula. Volume of one unit cell and total volume of unit cell into 100. Now substitute the value. Say value is packing efficiency. Volume occupied by one unit cell is 4 by 3 pi r cube divided by total volume. What is A here? A what is? A is equal to 2r. You already showed. So therefore it is equal to 2r the whole cube into 100. So you got the value as 4 by 3 is nothing but 8 cube, and you will get 52.4%. You will get 52.4%. So therefore packing efficiency in simple cubic is 52.4%. So therefore the space filled is only 52.4%. The empty space is more in simple cube. Are clear? So this is nothing but calculation of packing efficiency in simple cubic unit cell. Are you clear? We calculated the packing efficiency in FCC, packing efficiency in VCC and packing efficiency in simple cube. What are the values we got? In FCC, we got a packing efficiency as in FCC, packing efficiency as say 74% and here 52.4%, which is nothing but a simple. Just we shall have a summation. See, 3 derivation, and regarding your board annual examination, among these 3 derivation, 1 derivation definitely you will get. Are you clear? So you have to practice very clearly, and shortly I will give you the notes. You have to write down the notes in your book and you have to practice. You can easily understand. Okay? You have to draw the diagram which is given in your NCERT textbook, which is shown on the board. And all the things and the formulas you have to write according to your NCERT textbook. Don't refer to any other textbook. See, many diagrams, many manipulation is different. You have to be stick on to only NCERT textbook. Okay, so we shall have a summation. All these type of packing efficiencies, we shall just revise. See, packing efficiency, which is nothing but in HCP, which is also called CCP, or which is nothing but FCC. Are you clear? So this is the type of unit cell. So what is the value of A? Actually, A. We got A is equal to 2 into root 2R. A is equal to root 2R. Are you clear? And what is the value of percentage we got? It is nothing but 74%. That is the packing efficiency. The packing efficiency obtained in FCC is 74%. Are you clear? Understood? So what is the value of R here? What is the value of R? See, you got in the R is equal to here, you can easily write R is equal to what? Say root 2 R, root 2A, which is nothing but A by 4, which is nothing but the value of. So you will get one CET question. We will give the radius, you have to calculate the edge. Or we are going to give the edge length, you have to calculate the radius. So then in VCC, so in VCC, A is equal to what you got? You got root 3R by 4. Are you clear? And packing efficiency is nothing but the 68%. Are you clear? The remaining space 32%. Here remaining space, empty space is nothing but 26%. In simple cube. So you got here A is equal to nothing but 2R and the percentage is 52.4%. Are you clear? So these are nothing but you have to apply. What is the remaining space in FCC or FCP is nothing but 26%. Empty space. Then add this 70 will get 100%. You have to remember the packing efficiency formula. So it is nothing but volume of how much sphere in particular unit cell we found. So volume of 4 spheres in a unit cell, if it is FCC, and divided by total volume of the unit cell into 100. Into 100 you have to consider. Are clear? Understood? So therefore, these are the packing unit cell, type of unit cell. And here the value of edge length, and also if you know the edge length, you can easily calculate R value also. This formula you have to remember. Why in practicing you can easily remember. Just consider the triangle, then substitute the value. And packing efficiency in FCC is 74%, and in VCC 68%, and in simple cube 52.4%. See, dear students, whenever we ask some questions on calculation of packing efficiency. If particularly we ask HCP or CCP, some of the students making confusion. They are going to write body center cube calculation or simple cube calculation. No. First, very clearly see the question, then understand, then write the answer. Are you clear? Okay. So this is nothing but calculation of packing efficiency in simple cube. We will got as 52.4%. In a body centered cube, we got 68%, and in hexagonal closed packing, we got 74%. Are you clear? Okay. In today's chemistry class, by the same time, I think you are going to face a physics test. So whenever you are free, download it and you can watch the class. Okay. So be in touch with regular study. Okay. Thank you.